Yeah, hi Banu, you are audible.
Okay. Mm,
Shall we
just
start
give
the
me,
session? Is this
yeah,
set up?
meanwhile, if someone has any doubts, they can ask me. Meanwhile, I'm just connecting the board. I just came from the office, so it will take some 5 to 10 minutes of time. So, if people have any doubts, you can put that in the chat box, or you can directly ask me. I'll explain. Hello?
Guys, please
Mm,
try to ask your doubts. Did everyone understood yesterday concept? No doubts, sir? Shall we ask some questions?
No, no, it's fine. It's all about this is the thing where we are making you to train for the job interview on Linux boot for process and for the embedded systems, right? So it's on you guys. If you don't feel comfortable with the Linux bootloop process that I have explained yesterday, you can ask me if you have any doubts. If you got stuck anywhere, like I asked you to go through the Linux kernel source tree last day, right? So if you have been through the Linux source tree, if you found any something that you didn't understand, you can ask me, right? I'll explain you. Prayers and Print Latte and Srinivas. A few people. Where is the recording? What is recording? Hello?
Sir, I have doubt.
Uh, Hi, Prem.
Yeah, hi, sir. A very good.
Just 1 second. Someone is asking where is the recording. Sir,
Larger.
Sarat Babu, what recording you want?
Maybe he is asking for session. Yesterday session we already uploaded in the YouTube. You can just visit ProV Logic YouTube channel, and today's session also we will upload by tomorrow.
Yeah, Prem, you can ask me now.
Yeah, sir. The Linux boot flow, we we need we can understand the only physical side also, like only for the open the Ubuntu can using that type or when they turn on the device using the F12 like that. I'm
If
understand,
you
but
No,
default boot
if you're
source is ST.
comfortable in asking Telugu, you can ask me. I understand.
అంటే
And
సార్ అది ఇప్పుడు
mm,
ఎస్టర్డే చెప్పిన క్లాస్ ఓకే అర్థమైంది కానీ
mm,
బట్ ఫిజికల్‌గా గూడా డివైస్ కనెక్ట్ జేసి అండర్‌స్టాండ్ జేసుకోవచ్చా? లేదంటే ఓన్లీ ఫర్ ఈ బంటుని ఆన్ జేసినప్పుడే అలా ఏమన్నా ఈ బూట్ ఫ్లోని అండర్‌స్టాండ్ జేసుకోవచ్చా అని డౌట్.
what actually Prem is asking, whether we can boot the board only when we connected that to the Ubuntu running device, or we can able to directly run the Linux on the target machine. That's what the question you want to ask, right?
యెస్. యెస్.
Okay, so your question is pretty valid. So we have here the concept is like a host and target. The host is where the actual Linux like Ubuntu or Red Hat enterprises like Fedora or any CentOS or something like that. So those sort of OS which are running. So where you have compile install the toolchain. So this is called cross compilation. So you'll be compiling the images across in the sense like you have any target like a BeagleBone or Raspberry or any other board, right? So you will be compiling the images on the just give me a moment. I'll draw and explain. Yeah, the session is started. Hello, can you hear me?
Yes, sir.
Yes, we are able to hear.
Okay, great then.
Yes,
Uh,
sir.
so just give me a moment. I'll explain you how it works. So that's really important question Prem have asked right now. So I'll share my screen and I'll show you how it works. Can you able to see my screen?
Yes,
Yes,
sir.
sir. Yeah.
So here, this is your host machine, and this is your target machine. So this might be BeagleBone. Okay. So this is your BeagleBone, and this is your host machine. Somewhere like you'll be having Ubuntu or any CentOS or any Red Hat enterprises like Fedora, whatever the OS you'll be running on your host machine, it's up to you. No matter if you have any virtual machine installed on your Windows machine, that's completely fine. This is your host machine, right? So to up and run this BeagleBone, you need four components. The first component is MLO. It is like a first stage bootloader. Okay, as I have explained last day. And second component is U-boot. You know that one, right? And the third component is a kernel image, Z image. And the fourth component is like rootfs. Without having these things, your BeagleBone won't up and run. So like this is like if you don't load this is compile, this is whole package, you call it say OS. You got me right, Prem?
Yes, sir. Got it.
So for these images, we will be having this as a free source. Okay, so it is like a freely available in the internet. So this is like source. So it will be in the C language. So that source code will be downloaded in our host machine. Okay, we will be downloading in the host machine, and we will be compiling that this source code like MLO, U-boot, kernel image and rootfs in our host machine using the toolchain. That this is called like for the board like this board, we are compiling cross compiling, right? Okay, it's a cross compilation.
Okay.
So what we are trying to do is uh, so the images will be compiled in the host machine, and we will be loading that into an SD card. Okay, that SD card will be loading that each and every image into SD card, and the four components or OS components into the SD card, and will be embed that SD card on the BeagleBone, and we will choose the boot sequence like it's a MMC or SD card or USB. So that thing will be like based on the choice of selection for the boot sequence will be happen, right? So if you just chosen the SD card and the board will start booting from the last day I have told you, right? So this is the DDR on your BeagleBone Black. So the initial like I have said, will be having the boot ROM. So the initial code will be executed. It will load the FSBL from the SD card here. Okay, and then U-boot will be loaded here, and then like the kernel image will be loaded into the DDR, and then like the rootfs. So everything will be compiled. This is the source code is compiled in the host machine, and we will be copying that OS components like MLO, first stage bootloader, U-boot, Z image, kernel image, and the rootfs into the SD card, and this SD card will be embedded onto the like it will be like inserted on the BeagleBone Black. Uh, board, and then like if we choose if we power on the system, and if we choose the boot sequence, if we ask it to boot from the SD card, then initial boot run will be start executing, and that will load the FSBL into the first address of the DDR, and then it will initialize you, as I have explained last day, right? So the primary things of the first stage bootloader will be like it will initialize the further hardware, like it will also initialize the deep down the DDR again, and it will load the U-boot from the area we have mentioned. So this is how it works, okay? So we can also do that, like just the host machine we want for downloading the source code and compiling the images that are required for the system to boot up and run. Okay, so I hope I have answered your question, Prem.
Yeah, yes, sir.
You got me, or like if you have any further questions?
I have one doubt, sir. Okay. That host machine we can download for the this MLO, U-boot and kernel and robot. These all are downloaded in host machine. Is it correct? My understanding.
Uh,
This
you're just
OS.
yeah, you're just downloading it. You're just like downloading the source code. You will be like, as I have said, like last day, kernel source tree. I have shown that to you guys, right? So this is the
Yeah.
source tree. Uh, uh, well, wait, this is the source tree. So we will be cloning this source tree into our Linux machine, whether it might be Ubuntu or something like that.
Mm.
So we will be compiling all the modules and all the required, sorry, components, kernel components that are needed for the system to up and run. We will be cloning this thing. That is what actually I have planned to show you guys today. So like we will be cloning the source code. This is like the repository for the Linux kernel. So we will be cloning that, and we will be compiling it with the tool chain that we have installed. So we'll be like source the tool chain, the path where like to the shell, and then we'll be compiling it, and we will once the compilation is done, we'll be having the Linux image in our workspace, so that where we are working, and the same is applicable for the U-boot as well. So we have U-boot source code as well. So we will be cloning that, and I'll also like we'll also compile the rootfs. We have a few steps that are there. So by following that steps, we will be compiling the whole software from our target host machine, and we will be copying that four components that I have said: MLO, U-boot, and kernel image, and the rootfs into the SD card, and we'll be inserting that SD card on the BeagleBone, as I have said here, and then like we'll choose the boot sequence, so it will boot from there. It is how it works. Okay,
Okay.
Srinivas, you got me?
Yes, sir. Yeah, I got
Sir,
Okay.
is it
understand.
necessary to be the host machine, a Linux machine? Like, can we compile it in Windows also?
It depends, right? So, what actually we need to, I don't think it will work with the Windows machine, because, we need the Linux, like the tool chains the tool chain is a component where we need to compile the source code. So for the tool chain to install, we need the terminal. So we will be installing the tool chain, and we'll be sourcing that on the shell where we have installed, and also like the source code, go to the source code, and just like make the like downloaded source code, cloned source code, and like that it went, Safir. So for that, you can directly get, you don't for your, if you have only one laptop with you. For example, I can say like you have a choice of switching among the Windows and the Linux machines. It's of your choice, isn't it? So you can get directly ISO instruction, like Windows ISO, we can say. We can get that one. We can directly download that from the Microsoft website, so that like we will be loading that in the bootable pen drive. So first of all, we need to create the bootable pen drive if you wants to do. So like the bootable pen drive, it is of like, we are saying we are making our pen drive. Suppose if it is of 16 GB and the initial addresses of that 16 GB, we are making, wait, I'll draw and explain. So if this is like your storage, if it is your USB, so you are creating USB or an SD card, something like that. So this is of a whole 16 GB, okay? Suppose, for example, I'm saying minimum 8 GB we'll use. For example, if it is of 16 GB, so we will be creating the partitions. So one is for the boot partition and the other for the root FS partition. Okay, so what actually we are doing is like we will be downloading the ISO, something like that. So in terms of Linux, we will be downloading the four components like yeah, MLO and U-boot and the kernel image, something like that. Okay, so we will be downloading that and we will be loading that into the pen drive. So just to load these components, kernel image and the root fs. So just to load these four components, uh, and just to load these components into the pen drive, we have to make this pen drive as a bootable pen drive. So we have to format this normal pen drive to as a bootable pen drive. For that, we will be having in the if we are like doing that in the Linux machine, we have multiple components like we have software like Gparted. Even if you have Windows machine, we have Rufus. So we will be making the pen drive to be the bootable. What actually we are trying to do is like in the pen drive, this is actually the pen drive with all the these all are the sectors, like these all are the block sizes. So we are making the partitions like from zeroth address to some. Hello. Hey, Henry, can you please mute yourself?
Banu, whatever addresses we are going to, uh,
Yeah. So yes, you can ask me.
yeah, so whatever addresses we are going to assign, right? Those will be
Mm.
with respect to BeagleBone black configuration.
Mm. Oh no, it's like like when you're like burning your SD card, like you're loading images into the SD card, it's completely your choice. Like the first you'll copy the in the boot segment, in the boot segment, this is the boot segment and this is the root FS part. So this is the whole SD card you will be loading, right? So
Okay,
so
but
can
how will
someone
the
ask
board
him to
know?
mute himself? He's making lots of noise.
అరే
If possible, to can you remove?
Prashanti, are you there?
హలో బోల్ that guy is
Prashanti, are you there? Henry, can you please mute yourself, mate?
Subhash, you can mute it please. Hello Subhash. Hello. Hello.
Hello?
Yeah,
Yeah, can you hear me now?
yeah, I'm able to hear.
Yeah,
Okay,
yeah.
so hey guys, like if you people are like just turn on your Teams and just like leave the computer somewhere and you are just doing your stuff, that's not make any sense. Okay, it's all about like the people here asking some really reasonable questions and I'm answering him that. So please don't make your mic on and talk to someone else. That doesn't make any sense. Okay, if you don't have enough time to listen here, you can drop off. It's up to you guys. Okay. Yeah, someone is asking, what's like
Yeah,
Srinivas is
uh,
okay, straight. Yeah.
uh, I want to understand like how will the board understand like from where to pick the images from
That is
the
what
uh,
that is what
yeah,
so last day I have told you that the ROM code, right? So
yeah.
you I have asked you like the ROM code is responsible for doing all this stuff for you. So initially the ROM code is the one which will execute, right? So that ROM code, whatever we have in the board, we have three switches are there. So switch S3, S2, and S5, something like that. So this is boot switch, okay, and this is power switch, and this is reset switch. So when you click by default, the boot mode on the BeagleBone, by default boot method is like eMMC. So it will defaultly goes to eMMC block device and search for the bootable images so like the MLO, U-boot,
So
and kernel image. Okay. No, no, please listen, mate. You're like asking in the middle. I'm just trying to explain. It
yeah,
might
sure,
be
sure,
like
sure.
it might be clear your question, but people are interested in knowing the stuff from here on, right? So please don't
Yeah,
mind.
sure.
Okay, so
Yeah,
this
sure, sure.
when you press this button, it's like your choice of choosing, right? So if you just press this button and it will choose. So then the next choice is like the first priority is MMC, and the priority is like, and the second priority is SD, and the third priority is of UART, like a JTAG, UART in the sense like a UART is nothing but serially you can load that serially you can load the images into the DDR. That is what the UART is. The SD card is like I said, like you will be having the slot here. You'll insert your SD card here so that if the boot choice is like SD card, then it will boot from here. Okay, or else if it is embedded, if it is a eMMC, the embedded eMMC card is already inserted on it's embedded on the board itself, right? So it's the first choice where it will boot, okay? So if not like if you just in the booting, if you just enter like press this button and it will go to the control will go to the SD card. Whenever you insert the SD card, the things will be the OS will boot from the SD card itself. And if not, like if you again press it, like it will be the UART, and if you again press it, like it's a boot choices, okay?
Yes.
You got me?
Yeah, yeah, got it.
Okay, so
So so
yeah.
once it knows that it has to go to the SD card, so
Mm.
will it search from the starting address, or is there a specific address it goes to?
Uh, Basically, the boot sectors are the initial addresses of the block device we have chosen. If it is MMMC, the initial addresses of the MMC partition will be dedicated for the booting. Okay. So if it is like I will today, if we have some time, we will I'll show you the whole SD boot how it works. Or else like I'll show you the eMMC how by default if the boot partitions are available in the eMMC thing, how it will boot by default, because someone have asked without having connected to the host machine, how can we do the stuff, and also that's what the question they have raised, right? So even though we don't have the target, even though we don't have the host machine, now how we can just run our system like anything, right? We can boot our machine with the images that are there in the eMMC, right? So it is eMMC is which is embedded on the board itself, so it will boot from the eMMC part itself, okay? Or else like we want the external device to be plugged in like a USB or like a SD card. If we can plug that in, by taking the images from the external host, like by copying the images from the host machine, and we will be plugging that into the board so that the images will be taken from there and based on the choice we have chosen. You got me?
Yeah, I got it. Yeah.
And any other further questions? Please ask me the questions because people are asking really important questions. Vimal Khanna has said like screen is not visible. Is it not really visible now?
It's visible.
Okay. Um, yeah. So if you have any further questions, so you can ask me. Just give me 5 to 10 minutes because my board is getting ready. I'll show you the boot flow process and all.
Sir, this ML and U-boot and kernel image and routers, these all are provided by the default for vendor, or we can make it like a, for example, Beagle board. Mm.
Yeah, correct. So that's a really good question. It is of your choice, right? So based on the hardware you have, my context, for our context, I have chosen the BeagleBone for you guys to give you the demonstration how it actually works. I have chosen the BeagleBone Black, right? So it is the board, it is the hardware developed by the Texas Instruments. You got me right. So the Texas Instrument have already it is like the board developed by the Texas Instruments, right? So the software that are the software, the source code for the software that is the Linux image that is the source openly available in the internet. So okay, you can download that. So how we know whether the software that are compiling are applicable for the board that we have, whether it is compatible. Suppose we like lots of hardware is available. We have Intel boards available, Qualcomm boards available. We have AMD boards available, and a lot of FPGAs are available, isn't it? So how do we have to compile for the specific board? That is where you have a def config that is defined, right? So I'll show you that again. Today, like I'll show you how we are compiling the uh, the source code and all. Okay, so just give me a moment. I'm just logging from my target machine.
Okay.
Guys, I'm gonna stop sharing my screen and I'll share another screen, okay? So that where the
Okay.
hardware is there, okay? Sorry, the software I have compiled for you guys, and I'll share you the screen. Are you able to see my other screen?
Yes.
Yes.
Yes, sir.
So what, can you please tell me what you can see? The
That
Linux
Linux,
console, right?
yeah, Linux.
Yeah, it's my Linux, okay? So uh so this is where like I'm in the access. So people, you guys like are aware familiar with this Linux console, right?
Yes, yes. You are
So this
using
is my
Ubuntu or
host.
Yocto,
Yeah,
this
so I'm
OS.
gonna show you that. So this is my host target machine. Sorry, this is my host machine. So with this machine, you can see my screen, right? So this is
Yes,
my
yes.
host machine. Using this host machine, I compile all the software that are needed for the BeagleBone. Okay, so you can see here it is like a version of 5.15. Okay, 5.15 generic, and it is like Ubuntu. It is the stable version used by the Ubuntu, and it is compiled for x86 architecture. So the laptops are based off x86 architecture, isn't it? So so it is like the processor that is x86 developed by the Intel, and in the laptops we use x86 architecture. You guys got me right. So but for the embedded systems, we'll be using ARM 64, right? So 64 ARM processor will be having. I hope you guys got me.
Mm.
Okay.
Yes.
So I'll open. Okay. So I'm here at root, and I'll switch to the source code where I have downloaded the Linux source tree and the U-boot and uh, um, BeagleBone Black. So this is where the source code I have downloaded. I have differentiated the source codes like this. So one is like a kernel, the rootfs, and the U-boot. So from U-boot, you will get the MLVO and the U-boot.image. As I have said, like yeah, so U-boot and the MLVO are the components that we can get from the U-boot for the BeagleBone Black repository, and the kernel image and the DTB that are needed for the system. Last day I have explained about the DTB, device tree blob last day. Have you understand what is DTB last day actually? Hello.
Would be good if you give an overview of the TB once.
Okay, I'll again explain that. Okay, so that just remember. So these are the source codes. Like these are the repositories. So suppose I'll open three more tabs. Okay, so I'll PWT. So here I'm just going into the kernel repository. Okay, so this is the kernel repository, and Linux is the source tree. You know that, right? So in the Linux source tree, I'm here in. If you just ls, so last day I have explained about the arc. Arch is nothing but the architecture. So we are working on ARM64. So for that, in the architecture, the configs are defined. So whatever the hardware we have, hardware specific configs are defined in the architecture. Suppose if it is of x86, we just go into the architecture CD, like or else ls. I'm just opening Arch. If you just go for the configs here, so you can see the what is that like architectures here, right? So it is of ARM. ARM is like for the 32-bit. If it is of ARM 64, you have like 64-bit architecture, okay? And you can see here the microblaze, and the microblaze it's specific to the I think Xilinx thing. So RISC-V processor here it is, and x86 you can see here the x86 is for the laptops, it is for the x86. And yeah, so MIPS is the processor based on the million instructions per cycle. This is the processor, and Hexagon is another processor that is developed. Okay, so if you can see, these are the different types of architecture. If you just go into the ARM, so yes, like these are the possibilities. Like you can see here, like the boot in hardware specific things are defined here. So in the ARM, if you just go to the boot, you can see the DTs here. Okay, so these all are the DTS for the different boards. You can see here the BeagleBone AM335. This is the BeagleBone. Okay, so this is the hello. Hey,
Yes, we are able to.
Yes, sir.
can you hear me, right? Okay, so these are the BeagleBone because we have the BeagleBone, right? So after compiling, we can see here the DTB. So if you just, I'll just try to open this for you, and I'll show you what is actually the device tree is. Okay, this is the data structure. basically it gives the info to the kernel image. So these are it will include all the hardware components. So HDMI, you might be knowing it, HDMI, right? So the hardware it will be showing that the status is okay. So status, if it is like, I'll tell you the structure one by one clearly. Okay, so this is the device structure. Okay, so within this structure the hardware components are defined. So if it says the status is okay, it means that the device hardware is available, so that the kernel can establish communication between the user space applications and this hardware like HDMI. So hardware applications, like if you are playing any display HDMI, how we are using it to just connect it to the display, right? So for display, we'll be connecting, or like a HDMI cable, what sort of applications we use it for, we'll be connecting some display to any CPU will be connecting to the HDMI, right? So if you want to extend your screen, you can connect that to the HDMI port, so that you will be having multiple screens for your laptop or for your computer. So that is how it works, right? So how does the Windows, if it is Windows or if it is Linux, how does it know like multiple screens are available? So the HDMI, the kernel will be knowing it via system.dtb. Okay, so LEDs base, so here the LEDs are defined, and for your convenient, you people might be knowing. So this is like, base thing. So we have included another here, another DTSI. So here all the components are defined. So this is the major, this is the big DTS file where we have all the device tree properties are defined. So if you just consider the HDMI in our context now. So the HDMI, this is called the device node. So the kernel will be seeing it as a node. So this is as a device, and these all are called the properties of the device tree. Okay, so compatible, it is compatible for TI in the sense like Texas Instruments. Okay, so this is the Texas Instrument. If we use like some another AMD or like an Intel thing or Qualcomm thing, that might be the device tree might not be compatible for the board we have. So for that specifically, we just use the components like DTB and the U-boot that are only specific to the Texas Instruments sort of thing. Because if we go for the current Intel or like a Qualcomm thing, it won't be compatible for the hardware we have in our context. It's a BeagleBone. Okay, so the compatible says like the hardware it will support. Okay, and it is like I2C. So we will be connecting to the I2C bus. So, and the pin control lanes like default off. So when we just go deeper inside it, we will understand what sort of significance does each property have, and the status is equal to okay, in the sense like this hardware is ready for you to use. It will be the notification given to the kernel from the system.dtb. So you got me right. So you can able to
Yeah,
visualize what sort of significance does system.dtb have when it is booting with the kernel. Okay,
got it.
got it right, everyone?
Okay.
Just give me thumbs
This
up if
this
you
is
can
how
able
to
to
open for
understand.
this one. This is how can open for this one. Whatever the source code. Can you show me one more time?
This is the source code itself, like the human readable thing. So we
Okay.
as a humans have written this one. After compiling this, like the DTC is there, device tree compiler is there, just like tool chains are there, right? So in the tool chain we have a device tree compiler also. So the DT, uh, okay. The device tree compiler will compile the DTS file that we feed it to, and it will compile that, and will have the DTB just like here. Okay, so this is this main source file. Within this, we have included another AM335X DTS file, right? So this is how it works. So it will provide, the DTS will provide the hardware knowledge for the kernel at the time of booting. Okay.
Yeah,
So the
got it.
arch is important for the hardware in the arch directory. Whatever the hardware we are trying to use, all those hardware specific configs are defined in the arch. Okay, and if you just like look here, this is really important at the time of compilation. So the tool chain, like as I have, uh, You know, Bin. So if you just go down, if you can see here, the export arch is the now like if I source my bash RC, bash is like you people might be knowing it, right? So bash born again shell, you know that. So the shell, at least the people you can know that shell, right?
Yes.
Yes, sir.
Yeah. So you when you know the shell, you might be knowing the bash RC also. So the bash RC is the one like the shell. It will be like all the environment shell environment variables we can define in the bash, rather than like exporting that in the shell itself. We will be defining that in the bash RC. So like shortcuts, if you want, like you can like LL, LA. So these sort
Yes.
of things like aliases. If you just
Alias. Yeah.
don't, yeah. So alias thing is like you just don't need to enter the full command. If you just like alias ll is equal to, suppose here what I'm trying to say is like a cross compile for the variable cross compile by all the time, because if we have entered any spelling mistake, it is not that easy for us to understand where we have done the mistake in the command while entering. Okay, so that's the reason I have like a cross compile is the one we can able to easily enter, right? So that's where like I have made shortcut as like these things like if I explain, if I make them like export arch is equal to ARM, architecture I defined as an ARM, right? So architecture I have shown you like ARM as in the Linux source tree. I have shown you guys like arch block something like that, right, previously. So that is where like the architecture comes from. So the architecture here defined as a ARM, just ARM, and the cross compile in the sense like we are compiling the images, cross compilation we are doing, right? So this is my host machine, and I'm compiling this the BeagleBone specific things in the my host machine, and I'll dump that into the target machine later on, right? So for that, like a cross compile, what's the tool chain I need here for cross compile tool chain here is ARM Linux GNU ABI So this is what the tool chain compilation tool chain. Okay, I'm defining here like so this is how like whenever you just like exit here, if I say like a source, uh, the same here. If I say here, like if I enter like echo dollar, dollar arch, it will print the arm. You can see here, right? So like it might be like defined somewhere rather than like I can also do like export arch is equal to something like that. So I can also do like this, but instead of doing like this, I have defined in my bash RC. I hope you guys got me what I'm actually doing here. Okay, so those things like environment variables we can say, the shell variables we can say. So and like if it is like whenever like it wants to decode, the shell will be knowing arch, what is the arch by default, rather than picking up ARM64 x86 something like that. It will by default chooses like because we have sourced the bash RC here, right? So whenever it looks for the arch variable in the shell environment, by default it will be equal to the ARM market ARM. Okay, guys, give me thumbs up if you're okay.
Yes, sir.
Yes. Yes.
Great. So just like even you can, instead of arch, you can compile, you can check for the cross compile also. So it will give the tool chain, okay, tool chain name. So it is how it actually works. So the tool chain we have used is like this one, okay. And then this is the actually last day I have shown you in the browser the whole source tree. And when you cloned it, it will be the way you can see it here. So when you just like you can give commands like so I'm gonna give you the commands list after the session. So we will send it to you in the Teams or like in the WhatsApp group she will be creating, right? So in that WhatsApp group, she'll send you the commands how we can compile the source code. The whole Linux commands will be posted over there. Okay, so I'll explain again the U-boot source tree how it looks like, and then we'll compile it. Okay. So if you just go to /home. And BeagleBone Black. So here, if you just go to U-boot again, so this is the source tree for the U-boot. And if you just look here, these are the directories that are there in the U-boot source tree. So again, you have U-boot for someone has said like how do we know, or like how does the compiler cross compiler will know for which architecture are we defining, are we compiling, which hardware we are compiling the stuff and all. Even with the just like for the kernel, I have said like there is Arch. Under that, configs will be defined, and just like that, even here, the Arch will be defined here. So just like here, I haven't sourced my bash, and if I just enter like echo dollar Arch, it won't print anything because I haven't sourced my bash RC. Okay, so that like if I just compile here, even the so even if I compile my architecture, it will be like into the chaos situation. It won't be knowing that what's the architecture actually defined. It will by default chooses one architecture from the architecture defined here, and it will compile like that. But we have to be specifically building it for the Texas instruments, isn't it? So when we have defined it, so we have to instead of instead of defining the arch variable multiple times in each and every shell, the bash RC is the only one. If we define that in the bash RC, if we simply source our bash RC file, uh, dot bash RC, sorry. It is like a simple one step, right? So if you just go and print it, like you can, sorry. Uh, Okay, you got me right. You can able to see this, right? So after sourcing this bash RC, if I print the arc, in this shell, wherever you go and verify the arch variable, if you just echo means like we are printing the variable value. Arch is a variable, and we are printing the value of the arch. So what's the value here? Architecture, it is showing us ARM, right? So even in the U-boot also the same applicable. So these are the U-boot and the kernel image we are building for the BeagleBone. So to just make comfortable with for the tool chain, what is the architecture it have to compile? So if we define that arc variable inside the shell itself in bash RC, then we don't have to explicitly define the variable arc, but like we don't need to export the values to the shell every time when we are compiling. If it is defined in the architecture, this is not only it's the initial step, right? So this is the booting, compiling the kernel images and the U-boot for the BeagleBone Black is it's a first and foremost step, important step to do, right? So it is not like not yet like it is not only the final step. So this is really very very starting step, right? So once you're done with this step, every time you have to invoke your tool chain for building the stuff like user space applications. If you have any user space application you want to develop, it might be in the C. So if you want to work on that one, if you suppose for example if you want to develop any Linux driver, for that Linux driver to compile, you have to invoke your tool chain to just compile that one, and and just load that kernel module from after booting the board. So for that thing, all the time you are using your host machine for compilation. So that's why you have to define the arc and the to cross compile values in your bash itself, so that you don't need to just export the values all the time. You can simply source your bash rc, so that you don't need to do the exporting the arch values and cross compile all the time. It will be defaultly doing that for you from the behind the screen, so that it is up to you, right? Up to here, any doubts like with the U-boot or kernel?
Okay. These, okay, whatever you're explaining, U-boot and kernel, these all are vendor is providing. Just we have
Hmm.
download in our host PC, like any flavor you are using, Ubuntu or Yocto something, and then
Yes.
we can set up these all things only one time. Okay.
Yeah.
After that, when you are writing any source code, like any device driver programming, just we use for
Hmm.
this tool like host, and then compiling our source code and deploying to the our target board. Is it correct? My understanding?
Yes, yes, you are correct. So, Srinivas,
Yes.
what actually you said is correct. So, the U-boot, the kernel, we will be compiling only once if you
Okay.
have the hardware. Until unless if there are any upgrades, or like if there are any extra new features are there available in your upstream source tree, or maybe from U-boot, or like maybe from the kernel image, if you have that, until unless you have the feature development, you don't need to compile these things, right? So once you have these images ready, you are compiling it for very first time. So you have compiled the software, and suppose once you boot your system and once it is running up, later on, suppose you have the hardware in your system. So that is like a minimalistic, you see. The hardware is capable of doing more than the stuff what actually it is doing right now. If you want to develop a driver furthermore, you can add further features onto the driver what actually is there, so that on top of that, if the driver is of basic usage it is doing. So on top of that, if you develop the feature for that time, that you will boot the board with the previous existing images, and with that images you will be boot, and the module you will be like loading whatever the module you want to develop, you will be adding that into the kernel config, and you will be loading it, right? So you got me?
Okay. Yes.
You got me?
Yes. Yes. I got it.
Okay, so because we are suppose for all the people, for our sake, I'll consider here 84 people are there. So I'll just consider all the 84 people are like a kernel developers. So kernel developers in the sense like they'll be developing any, suppose Srinivas is interested in kernel scheduler, if he interested in developing the kernel scheduler. So suppose if we come up with any scheduling policy that if it is applicable and if it is willing for someone to use them, so that would be like the patch that would be applicable. It's a part of kernel, right? That's the new feature implemented the Srinivas, and it would be pushed to the upstream. So whenever you got the new patch available at upstream, you can compile it. If the patch, if you want to really use that feature, if you want to really use that kernel scheduler on your system, you can download that from the source code and you can compile it. You don't need to compile the U-boot and the rootfs again. You just need to compile the kernel image, and you will replace the old existing kernel image with the new kernel image. You can boot that normally. It is how it actually works. So the people like you guys are like every day you will be implementing some new features, or like from last 1 month or 2 months you've been working on some feature and you have developed, and that is like that's got like acceptance by the open source community, and you just put it up pushed it to the upstream. If it is accepted, and it would be pushed up, and if it is like a must and should usage feature for the people who are actually using the previous version of the kernel, they can clone that, and they can clone that from the remote repository, and like they can again compile the kernel image, and they'll boot the system with the new image. It is how actually it works. Okay.
O-
uh,
Okay.
any
What
doubts
I'm
here?
understanding, different two persons are there. Like one is the kernel programmer is there, one is the Linux programmer is the Linux device driver programmer.
Bro, it's like it's not like a kernel programmer, or like it's a Linux driver or something. So the
Okay.
Linux is the operating system. Okay. You got me
Okay.
right?
Like device driving, Linux device drivers.
Okay, okay, I will show you. Here you can see this is the Linux source code. Okay, just I'll explain you. So this is the Linux source tree. Okay, so whatever the components I have highlighted here, Arch, block, sets, crypto, credits, and copying, documentation, drivers, FS, include, init, IPC, cable, configs, kernel. These all are the stuff in the Linux source tree. So
Okay.
suppose if Srinivas as a kernel developer, if you wants to improve some security features, kernel security feature, you'll just go down here and if you just cd to security and what you can see here in the security, like whatever, suppose I'll just choose something for you. Um, security.c is here. Okay, so this is the security.c file. So if you just vim security.c, so you can see like almost like how many numbers of line is there. You can see mostly you can see like a 2560 lines of code is there. For example, if you just include some feature, if you just try to understand what actually security.c is doing, and on top of that, you want to implement another feature that is not actually available in this system.c. Okay, so if you want to add that feature, it is another kernel security feature that that developed by Srinivas, and you just push that into the upstream, so that if it is accepted, it will be merged into the source code. If it is not accepted, it won't be merged into the upstream branch. Okay, so you can see here git branch. Sorry. So this is the master branch. Linux Torvalds. Last day I have shown one picture of someone who have actually developed the Linux, right? So it will be like he will be the owner of this master branch. Whenever someone have made the changes, we have to make him convince him with the feature that we are developing. And once he convinced with the feature that we have developed, he will be merged into the master. Or else like you will be creating some separate branch, git branch. Uh, Suppose git branch hyphen b, suppose Srinivas or like a feature, I want to develop the feature, feature slash security, security slash security underscore dev. Okay, suppose I'm developing any security feature, I'll just check out to the feature branch. So sorry, this is git checkout hyphen b, feature. Suppose security I'm developing, I'm just interested in security. I'll just create this branch, and new branch is created on top of master. So now if you see like a git branch, which branch we are in, we are in the feature security dev branch, so that I'll be like, you know, ls, I'll be having the same source code. So the path, the straight line, like the previous master branch is there, and you are deviated from that branch, and you're on top of that master branch, you have created your branch, your feature security, and whatever the changes you made here at the security directory, you can make your changes here in the security. And so that like these changes will be pushed, like if the feature is acceptable for the open source community, if the people are convinced with the feature that you have developed, it would be pushed over there into the main this master branch. Okay, this is how it works. Srinivas, you got me right?
Yes, yes.
Okay, any further questions? So I have explained you guys with the kernel and the U-boot. So if you just go to the kernel, I'll show you how actually, because I we have like for compiling the kernel, it might take 2 to 3 hours of time. Just the kernel itself, it will take a lot of time for compilation, because we just have got nproc. If you just enter nproc, we our laptops will be having only 4 cores are available. So if you just open your system, like if it is quad core, it is of having only quad in the sense like 4 cores are available, right? So we just have got a 4 cores on our system. So 4 cores will be sharing the compilation process because it involves a lots of like Arch will be having a lots of stuff to deal with, and then the drivers, in the drivers there are lots of stuff. So to compile each and every driver and each and every kernel module, it would take a lots of time, right? So just because of that, it will take a lot of time. So what I'm trying to say is like I will give you each and every step to your end. If you have Linux machines available at your end, you can able to compile the each and every source code, so that like you can able to see how the Linux kernel image and U-boot image and system.dtb and also the ML of FSPL will be compiled. Okay, so I will be providing the each and every step. Just to save our time, we can discuss furthermore how the like how actually the booting will work. I just want to visualize you guys like how actually it is working. So that's what the plan here. Okay, so we will share you the PDF with the commands, how actually source code needs to be cloned from the upstream, and that will be shown to you guys. Okay. And also, if you guys have stuck at somewhere while compiling the source code, we'll be having on the fourth day, if possible, we'll be having one more 1 hour session. In that session, I'll be explaining doubts to the people who got stuck at somewhere. Okay, guys, give me thumbs up if you're okay.
Okay, sir.
Yes, sir.
Thanks, too. And yeah, so you got me with this slide. So if you just, I'll show you how we are doing it. So if you just enter the command, I'll just show you the command here. Just give me a moment. I'll share my screen and the screen. Okay, So, like for we have cloned the repository here, right? So we have cloned the Linux repository, and we just as we know that we are compiling it for the BeagleBone. So for the BeagleBone, we need to compile, we need to tell the toolchain cross compiler that we are compiling the kernel image for the BeagleBone Black. So what's the config? What's the name of the config that are defined for the BeagleBone is like OME OMAP 2 plus def config. Okay. So this is how like this config is specific to the BeagleBone Black. Okay, when you just enter this thing, it will compile the thing for no need to change config, because in the morning I have compiled it for the BeagleBone Black. This is the command you have to give. This is the way how you specify the compiler that I'm compiling the kernel image for the BeagleBone Black. Okay, so this is how it works. Any doubt here? Why we are doing this step? And if anyone don't understand, you just ask me. And the next command is like suppose make No, don't, none of them have any doubts.
No,
Make
sir.
menu con make menu config. It will open this console. Like you can see the GUI here, right? So suppose I have said like this, like everything is configured. Like whatever the configs you want to change, you can change here. So the boot options you can change here. Like if it is a flattened device tree, the device tree I have explained. If you involve more in the kernel development, you will be knowing that command line arguments you can edit here. So before start compiling the kernel, you can do whatever the changes here. So as of now, you people are bit familiar with the device drivers, right? So if you just go to the device drivers here and enter, it will take you to some other console, just like here lots of drivers are there. PCI support is there, and PC card and block devices like MMC and something like that. So NVMe support miss. So these all are the hardware configurations for the bus, for the BeagleBone Black. And if you just go to character driver, suppose if someone have enrolled for the next stage for the program that we like a Linux embedded Linux program that we are launching, so in the like after learning the C stuff and all, we will be implementing the character devices at some point, so that how character devices are configured here. So we can just go there, and if we have any our own character device driver we have, it will be pop up here, so that we'll be configuring it. So the star says it will be compiled with the kernel. If you just enter the space, it will be compiled. It won't be compiled, and if you just give star again, it will be compiled as a static module. M says like it's a dynamic module. It will be compiled not as part of kernel image. It will be compiled as a part of rootfs. So it will be there in the rootfs. And when you say insmod, this is a hardware random number generator core support. Then only it will be installed. Or else like when you just dynamically boot the system, it won't be there. It won't be available. So the star and M makes significance. If the space is nothing here, if you don't see anything here, it won't be compiled. Okay. So each and everything matters here, okay? So this is how we configure the configs for the kernel compilation, okay? And then like next the next command is like make uh, Z image. This is the kernel image. After compiling the kernel, you can see it as a Z image, and the command is like, we are just giving nproc dollar n nproc. If you just give this, it will start compiling. So it will start compiling the kernel image. So from here on, it will start compiling. So this is how it works. It will take a lot of time for you to compile the kernel image. Slowly it will compile, and so I'll just terminate the process here because it will take at least like 1.5 hours, and then next we'll compile the modules, and we'll compile the DTB. How we compile the DTB is here, the same command. If you just take off the Z image, and if you just like give the DTB, DTBS, it will compile the what's that like yeah, you can see here the DTB is compiled, right? So under ARM architecture, ARM boot DTS, this is the DTB we will be using it. Okay. Sarath Babu has been
These commands are changed to like compile, like these commands are using only specifically this board, or these commands are using another boards also?
the commands are same, but the def
Okay.
config I have seen like OMA OMAP2 plus def config I have defined here, right? So suppose if
Okay.
you have another instead of OMAP2 plus the def config, this would be given by the vendor. Okay, Srinivas, so this would be given by the vendor. Like a Texas instrument will say that you need to use the def config OMAP2 plus def config you have to use for the Texas instruments. So that is how the vendor will specify the def config, which def config we have to do. So if you are doing for the Raspberry Pi, the def config will be changed here, and the rest of the components and the rest of the commands will be the same. Okay,
Okay.
the same will be U-boot as well. And if you just go to the U-boot, just give me a moment. Uh, if you just go to the U-boot console, what's that, like pwd, so cd slash what's that, home, uh, legal on black U-boot. Okay, so here in the U-boot we are, right? So U-boot, and if I source my bash rc, and I just have to double check whether the shell can able to see the environment variables like arm and cross compile. Okay, so arch. So it can able to see the architecture, and it can also able to see the cross compile again. So cross compile, it have to see the tool chain as well. Okay, architecture and tool chain is really important. If you just go down there, and the first thing you have to do here is like you have to set that like which def config you have to use. Okay, so for the U-boot, you have to use the which def config. I have said like for the Xilinx, for the what's that, like for a Texas instrument, what is the def config we are using? OMAP2 plus the def config we are using, right? In the context of kernel. Whereas in the context of U-boot, what def config we are using is like OMAP AM335X underscore bone black AM335X underscore bone black underscore def config. This is the def config we have to use when we want to compile the U-boot for the BeagleBone Black. This is the def config we have to run initially, and then we have to just like do this. So you can see like yeah. So make proper, Mr. Proper. So it will clean everything for you. And again, if you just give this command, it will compile that for you, and it will store the def config. Again, maybe the name might be different. I'll just give you the correct name in the in the PDF that we are sharing. Okay. So this is the way we have to define the def config for the BeagleBone. The name needs to be really important when we are compiling the U-boot. Okay, so because you gonna get that U-boot and the first stage firmware, first stage bootloader with this U-boot, and the DTB and the kernel image from the kernel source code. Okay, this is how you do. You got me right? Hello,
Yes, sir.
you understand?
Yes. Is the U-boot compiling whatever you said? Some error it's.
Yeah, so maybe like I'm not sure the name. I
Yeah,
have to
I
double check,
understood.
and
Yeah.
yeah, I'll double check
Okay.
with the name, and I'll give you the proper name in the PDF. Okay.
Okay.
So this is I'm just making you to I don't want you to stick for the BeagleBone Black itself, but I want you to understand the context how we are compiling the U-boot and
Yes.
MLBO first stage bootloader, how we are compiling this as, right? Okay.
Sir, is there any sequence? First, we are compile the kernel image, and after that U-boot, after that MLO. Or if you have any sequence,
It's
you follow.
like while booting, it follows the
Yes.
sequence. First
Yes.
FSBL, then U-boot. No,
Yes,
first
sir.
boot ROM is there, right? So and then it is second is like FSDL and U-boot, and that is the way it follows. It just if you just enter the button, if you just press the button, then the flow will be taken care by the system. Okay, so it is the
Oh, no,
way
no.
how it works. Okay.
The compiling also. Same
For
sequence
the
we follow.
compilation, there is no sequence of
Yeah,
compilation. Okay, so you
yeah,
can
yeah.
compile your boot first, and or else if you want to compile, you can
Mhm.
compile the kernel image, so that you will be
Okay.
having the kernel image and the DTB, and later on, if you just have got some time and to compile the DT U-boot and MLBO, you can compile anytime. So it's you don't need to
Mhm.
follow the sequence.
Okay, okay. Yeah.
You got me right?
Yes, yes, I got.
So this is the compilation process. So
Uh,
yeah.
I
Mm.
have one more doubt. Yeah. So, as you said that it does not make sense to compile the source code again and again unless we have code changes. So, is it
Correct.
also possible to push a file or something to the target device and check our changes or test those?
Yeah, I didn't mean to say it doesn't make sense when you have compiled, because until
It
unless
it
you
will
make
take.
changes on, yeah, until unless you make changes in your kernel or somewhere, what is the need of compiling it? Because it is taking huge amount of time for you to compile, right? So
Correct.
if you can able to boot it, because if until unless you have big servers for you to run for your build system running, if you have, I have shown here, we just got only 4 cores or like 8 cores, or if it is octa core, it will be having 8 cores. And if it is of a quad core, we'll be having 4 cores itself. Among those 4 cores, the jobs will be switched across, and the build will be happening, right? So and yeah, so until unless it take less amount of time, you can compile all the time, so that you'll be using the latest kernel. While you have limited resources, like your laptop is limited with 4 cores, and you have less internet connection, less speed internet connection. So it doesn't make much sense in terms of compiling the source code every time when you want to boot. So until unless you see a very great change in the Linux code, then you have to clone it. You have to make your branch up to date with the remote repository, and make the kernel again compile
Got it.
before making, just run the make proper, make Mr. Proper, so that everything will be deleted, so that you can make menu, you just run the def config that is defined for that your hardware you want to build, and then make build. That is how the flow actually works, isn't it? So apart from that, you don't need to compile the kernel image all the time. It doesn't make much sense. So that is what I want to say. I hope I
Got it.
have
Yeah.
cleared your doubt.
Yeah. Thank you.
Hmm. So can we just switch to the boot process? I'll show you how actually physically we can boot the board. So I have BeagleBone ready here with me. Can I just boot that for you? If you are okay, I'll just start doing that.
Yes, sir.
Yes, sir.
Okay, just spare with me. Meanwhile, if you have any doubts, you can ask me, because it is I have to, it's been like long time I have turned it. So again, I have to turn it again. So just give me 4 to 5 minutes time. Meanwhile, I'll prepare it. Okay.
Sure.
Yes, sir.
Yeah, you can ask. Meanwhile, if someone is struggling in industry in terms of like interviews, you can ask me how to crack them. I'll explain. Or like you have general doubts, you can ask me. I'll explain.
Sir, I had one doubt.
Yeah.
So how can we start learning how to develop drivers for any specific board? How can we start it?
I know your level of understanding on the Linux. You
Excuse me,
understand
sir.
what I may I know what sort of leveling understanding you have regarding the Linux?
Sir, I do know basic Linux. Uh, I have been using Linux for past 1 year, but
Okay.
I do not know any. I do not have any information on kernel level. I wanted to
Okay.
know
So you,
if I'm working on any specific microcontroller like ESP32 or Raspberry, and I wanted, for example, if we take example of ESP32, if we are using any display or any sensors, we need to import their drivers in header file. So
okay.
I wanted to know if there is some work. I wanted to know how can we develop those drivers?
Okay.
How can we learn from for developing those drivers?
Okay. The first foremost thing is like, are you familiar with the boot flow process? How the Linux boot.
Yes, sir, I am understanding. I'm trying to understand and note down what you are saying here.
Sorry.
I do know boot flow process, but not too much. I do not know too much about it.
Yes, Dhruv, but you said like you've been working with the Linux with from the past 1 year onwards, you've been working on it, right?
Yes, sir.
But if you don't know the boot flow process, how can I suggest you to work on the device drivers? Because you might be knowing it how the boot flow process is the killer step for someone to enter into the Linux industry. Because apart from that, if you don't understand the boot flow process, how you guys know that where actually the drivers comes into the picture and how actually sort of like how do we know that whether the Linux is up and running or not? So you understand, right? What I'm
Yes,
trying to
sir.
say.
Yes, yes, sir.
Sir, can you provide us the specific steps for the boot process?
What?
Like, listen, can you provide us the like steps for the boot process, like in what sequence they are executing?
Mm. Yeah, so that is what, right? So the webinar is people just to collect the people who are really with this webinar, more or less from last day we can see lots of people are interested in learning the kernel. So this is how we get the students, and we will. It is our ProV Logic's responsibility in terms of making you familiar with the Linux and just make you guys to enter into the industry, right? So it's our responsibility. Just go ahead and took just put your next step into the ProV Logic and start learning from here on. That is what how it works, right? So most probably like 90%, 99%, I have provided you the understanding about the Linux bootloop process yesterday by drawing the block diagrams, and I have shared you the PPT. So I have shown you the PPT how it works, the boot flow and all. So maybe right now I'm gonna show you again how the boot flow works and all. So this is how it works, and once you you are interested in terms of cracking a job in the Linux, you are pretty much welcome to take your next step. But for you, everyone is interested in taking in getting in cracking the interview, something like that. But we're gonna filter out the people who have really understand the Linux from the webinar we have taught, and the basic programming knowledge that they have possessed from their bachelor's or somewhere. So it's the filtering process. We will filter the people, and it is how it actually works, right? So I hope I have answered your question.
Yes, sir.
Sir,
Yeah.
I had one doubt.
Okay.
So you talked about that for the driver's development, I do need to know Linux process, but if we are talking about specifically for ESP32, ESP32 runs on RTOS, not on
Yes.
Linux, if I'm not wrong.
Yes. Yes. Correct.
So
Yeah.
how can
ESP32, it's a separate core you are running. Okay. That is separate, and this is the embedded Linux is different. So how like even if you are into ESP32 background, you can be considered as a bare metal guy. So you are basically from bare metal. So for you, Linux doesn't make sense. Because you are off into that category, but you people are most eligible for Linux to learn. So because you will be knowing, basically, if you consider the ESP32 processor, there like we will be knowing when someone is working on ESP32, will be having great understanding regarding the hardware, what actually there. Okay, and if they know the hardware well, how actually the communication is happening among the hardware components and the processor running on the board, you can able to visualize how Linux also works. It's like a piece of cake for you guys to understand from here on. You got me through?
Yes, sir. Thank you, sir.
Yeah, so if you want to develop the Linux device drivers, I said like the gate is the Linux boot flow process. If you can able to learn this boot flow process from here on, if the people can able to know the boot flow process, the industry welcomes the people how actually the Linux is booting. From there, at least the boot flow process will make them to understand how device drivers are up and running, right? So the people can there on from there on they can do the bare minimum stuff with their knowledge. So the boot flow process itself, no one can visualize, no, like until unless you buy a BeagleBone Black, and if you do some stuff on top of BeagleBone Black, and if you can able to see it, you can only knowing it by that time, right? So you don't know until unless if you don't buy the BeagleBone Black, and if you do some stuff on it, you just maybe knowing like if you just listen to the story of Linux boot flow process, it doesn't make any sense for you to work on boot flow process until unless you do with your own hands. Okay.
Yes, sir.
Okay. So, uh,
So, what is the level of coding or programming that is expected for the test or the interview?
Shreyas, that's really important thing. Can you able to write sum of two integers code in C?
Yes,
Can you able to use the pointers in C?
yes, some basic pointers I can. There are
You,
also like more concepts and pointers, right? Like structure
yeah,
pointers. So
structure is nothing but integers and pointers. Sorry. You will be using both the structure will be using mostly pointers all the time. So anyhow, like at least like a C basic understanding of C is necessary. If you don't understand the C also, it's okay, but I said last day itself, right? So if you can able to solve the problem, if I said, if I give you the a quadratic equation and ask you to find out the roots for that quadratic equation, such level of understanding like how you gonna approach to the problem and how you are solving the problem is a must and should important for someone to enter into this domain. Now problem solving is must and should. In terms of solving the problem, you will be having some micro calculations and micro instructions involved in, right? So each and every instruction you need to consider while getting the proper solution, right?
got it.
This
Yeah,
sort of understanding is important. Okay.
yeah, yeah.
Uh, just give me a moment. I'm just gonna turn off the system and I'll share you the screen now. Can you able to see the screen?
Yes, sir.
Yes, sir.
Great. So, so this is the BeagleBone. This is the log. I'll again, I'll power off the board. So it is powered off now. So you can see here, right? Power down. Mm, So I'm serially connected. This is my host machine. So I'm gonna connect to the board, the host target machine, serially. Okay. So what I have used what's the user space utility I have used here is like a minicom. Okay. So minicom I have installed in my machine hyphen version. This is the minicom I have installed in my Linux machine. Okay, so with this user space utility, which minicom? So this is the binary. Minicom is the binary I have installed, and with this minicom, I'm gonna connect my target machine. Okay, so how do I check whether the target machine is connected to the just one second, it is booting up. So with the D message, if you guys are familiar with the D message, or can I assume that you people know the D message? What D message is?
Yes, I have to check the logs, latest logs.
Who is she? Viral. Sorry if I say your name wrong. What's your name?
Yes, Viral.
Viral. Sorry, Viral. Okay. So it is like to check the log. There will be like I'll draw the picture for you. Uh,
Yes, sir, I understand.
Not for you, as you know that, right? For the other people. Can you see the screen? So there will be like one buffer, kernel ring buffer will be there, like this. This is the buffer, ring buffer will be there. This is the kernel ring buffer. And whatever the system logs, it will be entered here, and the logs will be entered, and within the kernel ring buffer will be having the this is the structure for the kernel ring buffer, and in this kernel ring buffer all the dmessage logs will be available. This will be having some memory limit. I am not sure about the exact size of the ring buffer. Whatever the system at the time of system booting, all the boot logs that will be stored into this kernel ring buffer. And when you want to see on the screen, you just have to enter the command like dmessage. Okay, if you just enter this dmessg, you will see the kernel logs on just I have shown you that, right? So this is the way you see. So this is the dmessage command I'm running on my host machine. Okay, so dmessage I'm running on my host machine, and you can see there are like lots of failed messages you can see, and how like these are system logs. We can say it here. So these all are the system logs that we can able to see here. Okay. So whether to check confirm like RTW, so whether our system is connected to the target machine is connected to the system or not. How can we check here is like based on the logs that we have here. Okay, it's not reset properly. This will get you the last 10 logs. Like if you just mention a dmessage pipe to tail, it will only put you the recent messages that entered into the kernel ring buffer. Okay, if I just connect again the BeagleBone Black, I have taken off the connection again because you can see the failed messages over there, right? I'm just powering off my board and I have connected it back. And also I am powering my BeagleBone Black again so that it is powered now. And if I see again like the message, what sort of information will it provide? You can see here like previously it was a failed message, right? If I say like a D message tail, what's the last D message logs you can see here? CH341 UART. This is like a via TTY USB. Okay, so this is a serial console port that we can use, like from the board. So the board won't be having the display, right? So just to see the logs and just to see whether the kernel is booted on my machine or not, how can we see that? So that we can see here by the the connection is established via CH341 UART. This is the connector. Okay, this is a converter that will convert the serial logs from my board to the display. So this is responsible for printing whatever the logs that are there on my console, that are there on my system. It will be this hardware is responsible for building, running, printing the logs on my screen. Okay, so this is how it works. And so I'm going to launch, as I have said, Minicom is a tool. Minicom is a user space binary, which is used for me to connect to the board, right? So I'm going to launch that sudo Minicom. Sorry, the password I entered was wrong. You can see the logins here, right? So it is already up and running. So if we enter the logins, what might be the logins? Uh, the login is incorrect. Mm, I'm just missing with the logins, I guess. So here, if you can see, I just restarted the board. So you can see the boot menu, right? So as I have said, like MMC0 is the SD card. So it is by default, like if I don't stop, hit any key to stop auto boot. If I don't stop here, it will directly boot from the MMC1. As I have entered some button on my keyboard, it was stopped at a hit any key from here, and it was asking enter your choice. If I entered my choice, it will if I had my SD card inserted on my board, it will then if I entered one over here, it will boot from my MMC0, like, which is SD card. As I don't have MMC inserted on my board right now, so it will boot from the eMMC right now. Okay, or else like a boot from serial. It's like a serial in the sense like it's I can load it from serial from JTAG. Okay, it is another choice of loading it. Select Ethernet. If Ethernet, like, we can also load via TFTP or like NFS route, something like that. We can. It's our choice of booting the board. Okay. So for your understanding, easily understanding. For now I'm just using the default boot flow. It will choose the eMMC boot flow, right? So it will choose to boot from the eMMC. So I'm just entering the key 2, and it will start booting from here. Okay, so you can see here these are the dmessage logs I have shown previously, and you can see like I have chosen booting from eMMC. I have entered the key too, right? So it is booting from the eMMC, and I have loaded the images at the eMMC itself, and so this is how it boots, and welcome to Debian Gene. Like from here on, this is the Linux log, like this is the kernel log, and from here on it is the rootfs log. So Debian is the like rootfs that we have used here, and these are the logs that are specific to the rootfs. You can see, and with the dmessage logs is the one you can monitor the system health with the dmessage logs itself. If something goes wrong, it will be displayed in the D message. That's how like a D message logs are really powerful in terms of monitoring the health of the system. Okay, so and it stopped here at the logins. I really don't know the logins that we like. If I enter the password, so as I have said, right? So if I enter the password and the login name, then it will enter into the user space so that we can use the system completely. So that is where like up to here, this is the point where we have to concentrate because I don't know the passwords here and the logins. If I know them, we will just go ahead and see how login Linux is booted. But our concept is just to load here. This is the point we have to concentrate because this is the whole boot flow process. This we don't know how actually what actually when you enter the power button, this is all the work that is happening behind. Okay. I hope you got till this point of time. So maybe like we are just about to 9 o'clock, right? So it won't be sufficient for me to flash the images into the SD card and boot the system. Okay, so if you have any doubts in terms of booting the eMMC, you can ask me questions for this next rest of the time. You can see here, I'll explain starting kernel, start kernel, the kernel will start here. So up to here, like the U-boot is responsible and the MLO have done this stuff for us. And from here on, the starting kernel, flattened device tree blob, it is loaded at this location. These locations are this is the DRAM address. Okay, this address is the DRAM address. Okay, we have loaded the rootfs at this location. So RAM disk in the sense RAM disk. So RAM disk in the sense we are mounting the rootfs on the RAM. So that's why we are calling it as a RAM disk. Okay. So we are loading the RAM disk at this position. Hello.
Yes, you are audible.
Okay. You can able to see the screen.
Yes.
Okay. Any questions? Further questions? I'm really sorry for that. The logins, I have to check with the images because the logins are not there. I can't able to log in from here on. The password it is printing at the time of compilation itself. Debian, I'll just try with another.
How much time usually does BeagleBone Black take to flash image?
It won't take much time, but for the compilation itself, it will take long time. Once you have got the images that are available, you can load them, and it won't take much time. It will take just 1 or 2 minutes. you
Uh,
have seen here, right? So from this point of time, like this point of time to this is the choice I have entered here, and from here to here, what's the time it have taken? Just not even it is less than 1 minute, right? Boot will it will boot very quickly.
Sir, I have one doubt. So we are
Who is
connected the shall I shoot?
yes, 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 yes.
Yeah. So we have connected the BeagleBone using UART, right? Right now we are getting these logs from the UART, right?
Correct, correct,
Yeah.
correct.
So even before initializing the kernel, even before initializing the device driver, we have established the connection using UART. So how is it possible? Like we have not given
Perfect.
the correct
Yes, yes,
code, right? And
yes.
all.
Yeah, yeah. So you have said like at the time of initial starting itself, your driver is not up, and how can we connect that
Yes. Yes.
running, right? So okay,
Yes.
that is where like for these are called like not non-board specific drivers are there. Like that's a UART specific thing. It is not the kernel driver. It is like the minimum minicom. What you say like these logs are like appear to be from the series it will from the processor it will flush the logs. Okay, the minicom that is running in my host console. Okay, host console it is running. So whatever the logs hardware logs, you can say like till before booting itself, the logs will be popped out to the port called serial port. Okay, so it from the serial port, I just draw the picture and I'll explain. Really important thing. Can you see the screen?
Yes.
Okay, so this is the board. This is the host, I guess. Okay, and this is the target. And how actually we can see the boot logs is like we have a phenomenon, hardware have a phenomenon that whatever the logs is there, right? The serial port will be there. So the serial port is nothing but the TTY USB 0. Okay, so to this, it will flush the output whatever the thing, whatever the logs, whatever the system logs are there, it will be flushed via this port. Okay, so irrespective of the Linux boot step, like even though if it is like a bare minimum started, or even if like once you establish the connection, so you will go and connect to this port. Okay, so it will put even if it is at the 0th position, not even booted till you boot or something. If it doesn't, it just powered on. Soon the moment you powered on, no driver is up and running, but the hardware have a mechanism. Each and every board have a mechanism to just flush whatever the calculations, whatever the boot logs are there. It will be as by the hardware mechanism until the U-boot, that mechanism will take care of. It will flush the system logs to the serial console, so that like we will be seeing the serial logs up to that point of time. You got me?
Yes, but how is it is possible? Like it's perfectly like each characters are passed in the right way. So there should be some sequence of code for I mean some instructions, right? Like so
Correct.
is it
So that is the mechanism of the hardware. So the hardware mechanism which is responsible for printing every log accurately, that is how it is designed. Okay,
Okay,
so
okay, okay.
like yeah, so if it doesn't print that to you, suppose for example, from the layman way of thinking, if we don't know what is actually happening behind, if it doesn't print anything relevant to the hardware specific logs, how developer knows that the boot the system logs these types of checks are done, and we'll be having the post checks are there. Power on self test is there. So a power on self test will be done, and it will check the algorithm will check for whether the power is going for each and every peripheral on the board or not. It will be checked, and it will be giving you the indication that it is up, it is good to go, and then like the ram code will be running, right? So the ram code, then this is the way it will work. And like the hardware mechanism will give you the basic system logs. It will print you the system logs. It's on the hardware. Okay.
Got it, got it. And all the baud rate configuration will be preset, right?
Yes, the baud rate, like whatever the minicom. So I'll explain that to you again here. If you just okay, so I'll share another screen and I'll show you how we are configuring the baud rate. And hello,
Yes, yes, yes. Good. Yeah.
1 second. So if I again open the terminal and the sudo minicom, it will ask for the password. Yeah, can you see my screen?
Yeah, it's clear. Yeah, visible.
Which screen you are seeing? Okay.
Terminal, yes.
Sudo minicom hyphen s. Here, if you see, this is the minicom I'm running, right? Oh, it is very slow on your side, I guess. Can you please tell me what exactly you are seeing on the screen, Ron?
Seeing a terminal where it's certain
Configure account.
configuration parameters are.
Configuration file names and paths that you can see.
Yes, yes.
Okay, great then. So here, if you just go to serial port setup, from the port you here you can like serial. A is saying like the serial device, like I said, like TTY USB. So the hardware from the target it's a UART, but we are just connecting to our host with USB. Okay, one side is UART and the other side is USB. So that is where like the slash dev slash TTY USB. So the serial communication from the target will be seen by the host as a USB communication. Okay, that is where like a slash dev slash TTY USB 0 you can see there. Right, you got me right. And then
Yes,
like
yes, got it.
if you just go to baud rate, in the E option E, you can see BPS bits per second, per bits. 11,005 1 lakh. What's the amount like? 1,15,200 for the baud rate for the UART. That is the baud rate we usually set up, right? 9,600. Or if not,
Yes.
you can go for 11 5200 that we can do it, right? So this is how the baud rate will be set it up. So that is hardware mechanism to flush the system logs till the moment Linux boots up. From there on, the UART driver will be responsible in terms of pushing the logs to the host machine. You got me?
Yeah, yeah, got your point. Thank you.
Yeah. Any further questions? Please tell me about your availability for so we will be having the virtual interview once we're done with this webinar. Can you guys did she created the WhatsApp group?
No, sir.
Not yet.
Okay, so she will be creating it, and the questions will be posted over there. And in the questions, the one question is what's the like most of you this is the month of January, isn't it? We will be celebrating the Pongal, and if the people are not celebrating the Pongal, might be that is a good time for them. There will be a virtual interview for you. To crack the interview, you just go through the boot flow process and try to understand this. Okay, so once you guys are familiar with these things and some basic programming stuff, yep, please enroll yourself for the interview. That there is a minimum criteria that needs to be satisfied from the candidates, and once they satisfy the criteria, from there on, the training will be regressive. In terms of tracking the job, so that the training will be mostly based on the tracking job interviews, that would be like that. So it's of in the perspective of cracking the job, not in terms of making you learn stuff and all. So it's a very very quick and bullet short of thing, you can say. We will be straight jump into the concept rather than giving you the broad understanding about that. So only the people who have a broad spectrum regarding this boot flow process and the C stuff, you will be you will be training over there. That's how it works. Okay, so the people who are interested in terms of taking the interview, just register. Suppose if I can see here 63 members, if at least 60 members are interested or 50 members are interested, you just register and take the exam that will be conducted by the ProV Logic. If you're qualified over there, you will be forward to the next round, which is general oral interview, so that if you can able to clear that one, we will go ahead and we will train you for cracking the job, because you have cleared those two rounds only when you have stuff and all, right? That is how it works. So how many of you guys are doing the job and wants to switch your career, or if you wants to take the job interview, can you please raise your hands, giving thumbs up, or I'll just to know these many people are there. Shreyas have raised his hand for 2 times, and viral Prem Kumar, I can see, and Vimal Khanna, okay. Okay, and Hemasri and Srijita, Arbaz Khan, okay. C. Pavani, Emolio, okay. Manasvi, okay. So yeah, it's on you. So totally if you are interested in the job perspective, we will train you rigorously, and yeah, and if you are wants to learn everything from the scratch, it would be a bit different. We will feed you everything in terms of so it will take around 3 to 4 months of time. So it is how it works actually. And any doubts? I'll ask her to create the WhatsApp group tonight itself, so that you can join in that WhatsApp group. Okay.
Sure, that would be great.
Yeah.
సార్ ఇది లినక్స్ డ్రైవర్స్ మీద జాబ్స్ అప్లై చేస్తుంటే, అంటే వాళ్ళు అడుగుతున్నారు కానీ ప్రాజెక్ట్ చేస్తామని, బట్ అందులో ఏం ఎక్స్పీరియన్స్ లేదు, ఓన్లీ థియరిటికల్
Who
నాలెడ్జ్
is
అండ్
talking?
నార్మల్లీ
Who is
అంటే
talking?
బేసిక్ కోడింగ్.
I don't know who is talking.
ప్రేమ్
Prem, you're
సార్,
talking.
ఐమ్ ప్రేమ్.
Okay.
ఎస్ సార్.
Yeah. What's your
అదే
question?
సార్, లినక్స్ డ్రైవర్స్ మీద
Mm-hmm.
లినక్స్ డ్రైవర్స్ మీద జాబ్స్ అప్లై చేస్తుంటే వాళ్ళు నార్మల్గా ప్రాజెక్ట్ ఇలా అడుగుతున్నారు, బట్ అందులో ఎలా చూడాలో అర్థం కావట్లేదు. నా ప్రాజెక్ట్స్ ఏమైనా చేయాలన్నా లినక్స్ డ్రైవర్స్ మీద కొంచెం సజెషన్ చేయగలరా?
Projects, huh?
అంటే నార్మల్గా రెజ్యూమ్ షార్ట్ లిస్ట్ అవుతుంది లినక్స్ డ్రైవర్స్ మీద. సో వారు మళ్ళీ
Mm.
మళ్ళీ అంటే అందులో ఇంటర్వ్యూలో కూడా ఇన్ డెప్త్గా అడుగుతున్నారు, ఏమైనా చేసావా డ్రైవర్స్ మీద ఇట్లా, సో హ్యాండ్స్ ఆన్ ఎక్స్పీరియన్స్ అని.
అదే కదా మనం ఇక్కడ చేయించేది.
అదే అదే.
Okay, okay. So, driver experience, I said like the interview, if your people are interested in cracking the interview, so we will train you for the interview in terms of cracking the interview. It's all from there on like some sort of like every company will provide you the training, initial training. They don't train you everything from the scratch, but they will train you until unless you don't know the boot flow process, you won't get somewhere. If you know the boot flow process and the flow how it works in the companies, if you know that, you will be like feel comfortable after joining any company. Okay, that is how we train you, Pray. So
Okay.
yeah, so once you you are into the Linux background, right? I hope you can able to clear this
Yes, yes.
initial virtual and the coding, the initial round of written exam, so that we will talk there personally then. Huh?
Okay. Okay.
Yeah. Okay, guys, I'm dropping off for today. If you have any further questions, you can ask me tomorrow. Okay.
Okay, sir.
Sure. Thank you.
Thank
Sir,
you.
thank
Thank
you.
you, everyone. Bye. Good night.
Bye bye.
Thank you, sir.